In this series of videos, we'll show you how we can machine this part that we've imported into the 3D CAM module. So the first thing that we'll look at is the roughing. Okay, so the roughing needs to be created from a piece of round stock. So to produce that round stock, what I've done is I've used the solids menu here and created a cylinder, which is here, and I've typed in the sizes and the position of the cylinder. And if we make it partially visible, you can see that that's the stock material that the roughing cycle will use. To use that stock in the simulator, we need to save that cylinder away as an STL file, and to do that we right click here and say save solids, and then that can be saved into a folder of your choice and given a name which you can recognize later on. So I'll just switch that off again. So the roughing cycle is here, and the parameters we've set the spindle speed and the feed rate. The tool we're using is a 20mm end mill, and for the surface paths we've used triangle mesh and rough. The machining surfaces are the model itself, and I've left a 0.5mm finishing allowance on that. The constant depth step is set to 20. You can set this to your desired value, and the maximum step over is 10mm. Now I'm using an offset toolpath, but you may choose to use parallel or adaptive. The heights, we are using it to automatically calculate the heights, but using the minimum and maximum dimensions from the stock model, which is the cylinder we created previously. Under the roughing tab here, we switch on stock definition, and we've set that to surfaces, and the stock surfaces are that cylinder. So when we choose that, we can click on the cylinder and press enter, and that sets the cylinder to be the stock. The approach movements, the ramping is set to automatic. What this means is that it will ramp in at an angle where it has the space to do so. If it doesn't have the space to do that, it will use the helical milling. If you want to, you can force it to always use helical milling, but the automatic is a good way to start. The angle of the ramp and the amount of tool diameter used for the spiral helical milling can be set here. Under the surface paths, the depth step was set to 20, but that may or may not clean out all the individual flat areas that it finds. So to machine those, we choose advanced and check the box machine flatlands. This will find any flat areas that don't coincide with an exact multiple of 20mm. Under the link tab, we need to switch on that we want it to use the ramp in all circumstances. The retracts are set here, so we can set the height of the clearance plane, the rapid distance, and these feed entry planes here. So when we've done that, then that will calculate the surface, and that's now recalculating here, as you see. Okay, so I've got that switched off currently, so if I switch it on, that is the roughing toolpath based on the stock model that we've given it, and you can see there the helical ramping where it can't fit in the angular ramping. The stock machining will always start from outside of the amount of stock that we've created. So to see the simulation of that, we go into Simulate, and here what we need to do is we need to import the stock file which was used for the stock, and that was the one that I created from the cylinder here when I said save as. So we can simulate that toolpath. That's now preparing the data for the simulator. So it calls up the simulator. This is the stock model that we created. The toolpath can be switched on and off, and the mode can be set to length mode. So if we just slow that down slightly, you'll be able to see that here it's using the helical ramping into those pockets, and now it's machining around the outside. So if we just let that run, I'll speed up the simulation. So this is using the offset tool method, but you can equally use the parallel tool, or to control greatly the number of passes and the amount of cutting, you can use adaptive. Okay, so I'll just stop that. So we can exit the simulator and go back to our next path. So if we switch off the roughing path, the next thing we need to do is, there were areas in here which were not able to be machined with that large tool, so we need to rough those out. So for that we've used rest roughing. So this time we're using a smaller tool, but the machining surfaces and other things are set here. The height, I've set it to -17 so that it doesn't machine into the center bore, because we don't need it to. And the rest roughing is switched on here. So this is the roughing tool which we used previously, which is 20mm. Doesn't have a corner radius, although if you have one you can use it, and that will calculate just the tool path based on what material was left from the previous operation. So we don't need to use roughing, and the links we can set those to ramp if we want to. The size of the tool is smaller, so we have a constant depth which is smaller and a step over which is smaller. So that will calculate the roughing, the rest roughing toolpath. So if we switch that on, you can see that here where it's just machined the areas that it was not able to get into using the larger tool. And again, if we look at some of the other parameters on there, we don't need to use machine flatlands because we didn't need to, and that's all we needed to do there. So in this video, that was the roughing toolpath and the rest roughing.